There are two interesting properties of a hyperbola that we've seen, and it turns out both of them are pretty useful for in applications. So the first was that for any point on a hyperbola, the difference in distances from that point to the foci is always a constant. And then the second was that rays emitted from one focus in a hyperbola, once they bounce off of the hyperbola, appear to be coming from the second focus. So let's look at the first one first. So this property is pretty useful in situations where you need to perform some navigation. So the GPS system actually uses this idea with some adjustments for factors coming from special relativity. But even before the GPS system, there was an ocean navigation system called LORAN that used the same idea. So suppose you need to figure out exactly where you're located. So the open circle here is going to be our location. So as part of this navigation system, what you would do is build some stations on the shore, probably, that emit timing signals, right? So they're going to rapidly emit these timing signals. And in your navigation receiver, at our location here, we will receive these timing signals and then figure out what the difference in time is, the difference in time it takes for these signals to reach each station, to go from each station to us. So when we listen to these two stations, what we can figure out is the difference in distance between from us to these two stations. Well, if we have a constant that is the difference in distance from us to these two stations, that means we know we are on a hyperbola where the difference in distances to the foci is given by whatever difference we calculated. So just by listening to these two stations, we know that we're somewhere on this hyperbola. Of course, that doesn't totally fix your position, but you'll have more than two transmission stations. So then you can listen to these two stations. And using these two stations, you can figure out the difference in distances to these two stations. But again, that tells you that you're on a hyperbola that has these two stations as the focus. So that's going to be something like this, right? So these two stations are the foci of this second hyperbola. So this red hyperbola. So now we know we're on the black hyperbola and on the red hyperbola, but if you look carefully, there are several intersection points that might be our location, but we can either build another station or use these two stations to get another hyperbola to fix our position. So using the station at the far left and the station at the far right, we can figure out what the difference in distance to those two stations is, and that means that we can know that we're somewhere on this blue hyperbola. So if we know we're on the black hyperbola, the red hyperbola, and the blue hyperbola, there's only one possible location, and it's this intersection point. So this principle has been used in several navigation systems in the past. Okay, so what about the second property of hyperbolas, this reflection property? Well, think about if you want to design a flashlight. What makes for a good flashlight? Right, what a flashlight should do is it should emit a cone of light like this. Not really a parallel beam of light, right? In some applications you would want a parallel beam of light, but to illuminate a large area you need a cone of light so that the light spreads out, right? We've seen that if you use a parabolic reflector you'd get a parallel beam of light, but that's not what we want in this situation. So to get a cone of light, all of the light beams that are hitting whatever object you're looking at, all of these light beams ought to be coming from the flashlight like this. In other words, they should all be converging towards some point. Well, all of these light beams are coming from the lamp in the flashlight, so it seems like the one thing to try would be, right, have your flashlight have a lamp in it, like this, and all of the light would just come from this lamp. But the problem with this way of doing it is light is also going to come out of the back of this lamp, and it's all being wasted. It's just hitting the inside of the flashlight, and then it's just absorbed, I guess. So what we would like to do is actually reflect all of this light as well. In fact, that's most of the light of the flashlight. So what we need is some sort of reflector that will take this light going backwards and reflect it out forwards in a way that it forms a cone. Well, that's a job for a hyperbolic reflector. So if we have a hyperbolic reflector here, and we put our lamp at one focus, remember the other focus, right? The other focus is over here somewhere. All the light going backwards is going to get reflected so that it appears to be coming from the second focus, like this. So we get this diverging cone of light just like we wanted. Of course, the light going forwards doesn't look like it's coming from this left-hand focus. It looks like it's coming from the right-hand focus. So you actually get two cones superimposed on top of each other. In fact, some lamps in this sort of reflector setup actually block out the light that's going forward or reflect it so that it also goes backwards, so that all of the light is bounced off of the hyperbola and forms this nice outgoing cone.